Okay, quick recap. So getting us back into mechanics mode as well, I haven't done a lot of pure. So we need to look at momentum and impulse in 2 dimensions, and then we can use that in extending the work that we did last year on collisions, so we can start looking at oblique collisions. Conservation of momentum. So momentum before a collision is equal to momentum after. And impulse is equal to change in momentum. So impulse is mv minus mu. The other way we looked at impulse was force times time. I think they were the units we used, but it's force times the time that force is applied will also give you the impulse. Impulse does have direction, it has positive, negative, etc. direction, and the units for impulse, just to remind you, are Newton seconds. So force times time. Extending into 2 dimensions, we're basically working with vector quantities. So if your velocity is a vector now, I can just do that, then the same rules apply. So it's just really recapping what we're doing, but just adding some vectors in. We're not going into 3 dimensions, so we're stopping at 2. I'll go over 4 examples. I haven't been very unique with these. Sometimes I try to be a bit more unique. So they are the examples out your online textbook, but I've just kept life easy for myself. So anyway, I will go over them with you so you can see what's happening. So the first one, a particle of mass, sorry, just get lined up, 0.2 kilograms is moving with velocity 10I minus 5j meters per second when it receives an impulse of 3I minus 2j Newton seconds, and we want to find the new velocity of the particle. If you're anything like me, you prefer column vectors to i's and j's, which is absolutely fine. So impulse is change in momentum. The impulse is 3 minus 2. And that's equal to mv. We're in SI units now because we're doing mechanics. So just check you've got your SI units as well, which is fine, it's kilograms. So 0.2 v. You should be underlining these because they're vectors. And then minus 0.2 u, which is 10 minus 5. That gives us 0.2 v is equal to 3 minus 2 plus 0.2 times 10 is 2, and 0.2 times minus 5 is minus 1. So 0.2 v is equal to 5 minus 3. And so v times 3 by 5 is equal to 25 over 50 minus 15. So no more complicated, it's just working in vectors. Second example, which I think I put on here. A squash ball of mass 0.025 kilograms is moving with velocity 22I plus 37j when it hits a wall, and it rebounds with velocity 10I minus 11j. Find the impulse exerted by the wall on the squash ball. So impulse is equal to m, and it's MV minus MU, so you could just incorporate those in if you wanted to. You don't have to do anything complicated with this, so that's V minus U. So in a sense, is it easier? You don't have to really overthink the directions like you do when you're working in one dimension, because the vectors kind of do that work for you. So I is equal to 0.025. 10 minus 22 is minus 12. Minus 11 minus 37. My son's here, he could do this for me. Minus 48. And so the impulse is equal to negative 0.3, negative 1.2 Newton seconds. Obviously, you can just pop that into a calculator, and you will be using decimals a little bit more because it's mechanics. And remember, if you're using G, that your answers are only sound to 2 sig fig. I'll do 2 more examples, but I'll stop this recording before I run out of battery.